Today topic is cat- cutting parameters. Cutting parameters are shown below. Cutting feeds, depth of cut, cutting feeds. Cutting feeds is defined as the speeds at the which the work rotated with respect to the tools. In the case of CNC turning, CNC milling, cutting fields is defined as the fields at the which the tools rotate with respect to the work, usually measures in the meters per minute. Cutting fields is also sometimes called as surface fields. It is the length of scarf generated in the meters in the 1 minutes formula of a calculate cutting fields VC pi multiplied by D multiplied by N upon 1000. VC is cutting speed is a meter per minute. Pi is a 3.142. D is a diameter of components is mm in the milling. It is a diameters of the cutters in mm. N is a revolutions per minute of the spindles RPM. Example is if a job is to be cut at the cutting speeds of 200 meters per minute and its diameter is 60 mm, then what is the RPM of the spindles N? 1000 multiplied by VC upon pi by D. N 1000 multiplied by 200 multiplied upon 3.142 multiplied by 60. N is equal to 1060. This is a value. Constant surface speed is a CNC lathe machines with the G49 code. The surface of a cutting speed remains the constant as the diameter changes, the RPM change accordingly. So as the maintain the constant cutting speeds. Therefore, when G40 G96 is the commanded in the program as the diameter reduce the RPM increasing and the diameter increasing, the RPM reduce. G97 code is used cancel the CSS. G92 code is used is a limited of a maximum RPM spindle can be taken in respective of the value commanded by the G96 of CSS. In the case of a CNC milling, the formulas of a cutting speeds is used to calculate the spindle RPM. Generally, the cutting speeds is the mentions on the backsides of the insert box that can be used. A guide from HSS cutting began using for machining milled steel cutting speeds of 25 to 30 meter minutes can be used, whereas for the solid carbide cutters of a cutting speeds of 80 to 100 meter per minute can be used. Example of cutting speeds: first it VC 200 meter minutes, diameter 100 mm, find RPM. VC first is 636, VC 250 meters per minute, diameter 80, find RPM is second is 994. VC 150 meters per minute, diameter 120, find RPM is 397. VC 175 meters per minute, diameter 50, find RPM 1113. Fifth, VC 300 meter per minute, diameter 200 mm, find RPM. Fifth is 477. Feed. Feed rate is defined as the distance the tools travel during one revolution of the part. The unit for the feed is minute per revolutions. Feeds can be also be programmed in the minute with the use of a upright G code. When the feed is programmed in the minutes, then the work piece travel that much distance in 1 minute irrespective of a RPM of a spindle. Depth of cut. Depth of cut is the thickness of a metal that is removed during the machining. The perpendicular distance measured between the machinist surface of a uncut surface of the workpiece is taken. It is measured in mm. In CNC turning, is the diameters of a raw materials is 50 mm and diameter of a finishing parts is 47 mm. Then depth of cut is 52 minus 47 is 2. That is a 1.5 mm. Therefore, is a turning. It is the radical distance the tools pendant in the workpiece. In the CNC machines, it is the perpendicular distance measured between the machinist surface can be the uncut the surface of a worksheet while detecting the cutting speed and the depth of cut. Following thickness must be kept in the mind. First, has the depth of cut increasing, the cutting loads of on the tool's spindles and the X areas. Second, as the fields increasing, the cutting loads on the tool's spindle can be X increasing as the cutting speeds increasing, the cutting loads of a tool's spindle can axis decreasing. Fourth, as the tool nose radius increasing, the tool's load increasing, the finish and the dimensional tolerance achieved on the component reduce also. Which smaller tools nose radius we can work with the better LD radius, bigger tool nose radius with the LD radius of the more than 3 many leads of vibrations and the chatting. Usually, as a thumb rule, the cutting loads on the spindle and axis should not be more than 60 to 70%. Check the cutting loads of a spindle and the X wheel tools is the actually cutting the materials which the accelerations offer deaccelerations of the spindles. The cutting loads of a show of a spindle load meters in the very high because at the point in the times the motors always draw very high current. Don't use the reading of a spindle load of a guide uh, determine cutting parameters, the dimensions of a surface finish power requirements and the materials removal rate. As a feed increase and feed reduce, surface finish improve. As a feed increasing, the chips breaking become more effective in the machining. Chips breaking and chips evaluations is as important as the materials cutting in itself. It is that any tools functions apparatus is used at also feed. We know that as feed reduce of cutting loads increasing, which may leads to the breakage of the tools point.